All right, this is how DNA replication works. All right, so step number one, our DNA helix uncoils, all right, and now we have this ladder-like structure with the hydrogen bonds along the center. First things first is this enzyme helicase here comes in and breaks apart these hydrogen bonds, and wherever helicase stops is what's called the replication fork. Now, to make sure that these strands here don't reconnect, we use the single-stranded binding proteins to hold the two strands apart from each other. That's the wrong one. All right, there we go. Now, after that, RNA is laid down by RNA primase, so it acts as a prime for our DNA polymerase 3, so it can start synthesizing the new strand of DNA, like so. Now this moves along in the 5 to 3 direction of the leading strand. Now this one is simple. Next comes the lagging strand. It's not quite as simple. Now, because the lagging strand runs in a 5 to 3 direction like that, and our DNA polymerase can only lay things down in a 5 to 3 direction, we now lay down the RNA over here with the help of the primase. And once we get there, we can add the DNA polymerase 3 and continue along making the strand. Now the problem here is that eventually you're gonna have to stop and make another fragment following behind the helicase. So now what's gonna happen is I'm gonna stop the video, build the strand, and come back when it's done. So now that the strand is completely built with the DNA going in a 5 to 3 direction on both strands, what happens next is DNA polymerase 1 comes in here and replaces the RNA with DNA to complete the synthesization of each strand, like that. Now, on the lagging strand, there's RNA in multiple places because you can't, as it goes in the 5 to 3 direction, this is 3 to 5, so you can't build following the helicase. So now, these fragments of DNA in between the RNA are called Okazaki fragments, all right? That's what these are here. Now, the same thing happens, DNA polymerase comes along, moving in a 5 to 3 direction, replacing the RNA with DNA. Now, once that is done, there's little notches in between the fresh DNA and the already placed DNA. So what happens is ligase comes in and glues the strands together, completing the process.